Alright, so let us continue with the practice of the questions on work, energy and power. This is our video number 2 on question number 2. So here you have the question which is split across 2 screens because it is a long question. So if you want, you can pause the screen here, attempt the question, the first part of the question, and then come to the second part of the question which is on this screen. You can pause the video here as well and attempt the second part of the question. It is always a good idea to attempt the question yourself first before you look at the working of it. Why is it important? Because that ways you'll understand your weaknesses, and when you'll work on your weak areas, you'll improve your scores in the exams. Alright, so here is the question. I'll come back to the first screen, and I believe that you had paused the videos of the question yourself and you're coming back to look at the working of it. And when you are looking at the working of it, please keep scoring your working along with me to see how much total marks you got in each of the questions. So that's how you should be practicing the past paper questions. And simultaneously at the same time, please find some time for me to subscribe to the channel, to like the videos on the channel, and to also comment in the comment box to let me know what you liked about the videos. This will help me a lot. Right? So here it is. Here is the question. A motor is used to move bricks vertically upward as is shown here. The bricks start from the rest and accelerate for 2 seconds. The bricks then travel at a constant speed of 0.64 meters per second for 25 seconds, and finally the bricks are brought to rest in a further 3 seconds. The total mass of the brick is 25 kgs. Determine the change in the kinetic energy of the bricks in the first 2 seconds. So what is happening? Let me explain it to you. I know it is easy to visualize what is happening, but still let me make it more explanatory. So you are starting with a velocity of, you are starting from rest. So rest is a key term which you should always pay attention to, because it has information which tells you that you are at a velocity of 0 meters per second and you're accelerating for 2 seconds. You're accelerating for how much time? This time is 2 seconds, right? The brick then travels at a constant speed of 0.64. So at this point you achieved a speed of 0.64 meters per second. Then you are traveling at a constant speed for how much time? For 25 seconds. For 25 seconds your speed was 0.64 all throughout and between this region your speed was 0.64 for how much time? 25 seconds. 2 seconds acceleration, 25 seconds of constant speed, and then you decelerated and then again brought to rest. Brought to rest means you are again 0 meters per second in how much time? 3 seconds. So this is a data which you should visualize when you are reading the question. So there are 3 parts of the motion. First part, acceleration. Second part, constant speed. And the third part, which is deceleration. Right? You should visualize it. You need not draw it, but I have drawn it so that everybody understands, whoever is watching the video. So determine the change in the kinetic energy of the block in the first 2 seconds. In the first 2 seconds, what is the change in the kinetic energy? Change is always final minus initial. Right? So change in the kinetic energy, change is denoted by the letter delta. Change is always denoted by the letter delta. Change in the kinetic energy will be the final kinetic energy. What is finally the kinetic energy? This is the kinetic energy. So half the mass is given to you. 25. The formula, let me write the formula first. The formula for kinetic energy is half mv squared. This is the formula that we are going to use. So half times the mass is 25, and what is the final velocity? 0.64 square, minus what is the initial kinetic energy, because the velocity is 0, so the kinetic energy, initial kinetic energy is 0. Now you'll have to take out your calculators, work this out in your calculator and see if you are getting the correct answer by tallying with the mark scheme. I'll show you the mark scheme now. See, they have also done exactly the same thing. You should be getting 5.12 on your calculators. 5.12. Alright, so this was easy. And now they are saying the next part. You start reading from here. Determine the change in the kinetic energy of the block in the next 25 seconds. In the next 25 seconds, what is the change? So many of you all would have already identified, because that the initial and the final velocity are 0, so the change is 0. But let me write it down for you. So half 25 times the initial velocity was in the next 25 seconds 0.64 square minus half times 25, and what was the final velocity? Final was also 0.64. You need not write all these things. It's very clearly evident that the initial and the final velocity are the same, so the change in the kinetic energy is 0. Hence it is a 1 mark question, because it is easy to solve, right? Now they are saying change in the kinetic energy in the final 3 seconds. What is the final velocity? It is 0, right? So let us find change in the kinetic energy. First we'll find the final kinetic energy, which is half m. Final velocity is 0 minus half times 25 times 0.64 square. So which becomes 0 minus this whole thing which you have already calculated here. So minus 5.12, or your answer should be minus 5.12. So the total change is a negative number. It's okay. Even if you are getting a positive number, if you are changing initial from final, examiner will take it as a correct answer, because it is just a 1 mark question, right? So do not worry. But if you are using all the logics correct, logically, your answer should be negative. But even if you are making some mistakes and subtraction for finding the change initial minus final you're doing, still the examiner will not be so strict here in marking your answer. Both the answers are accepted, negative and positive. Alright, so this is done. Here I'll show you the working again. Easy question it was, right? Based on the formula. Let us move on to the next part. The bricks are in a container. The weight of the container and the brick is given to you. Calculate for the lifting of the brick and container when traveling at a constant speed. The gain in the potential energy. So when this whole system was moving at a constant speed, you have to find the gain in the potential energy. So the first part of the question was a practice on using the formula for kinetic energy. Now the second part of the question is a practice on using the formula for potential energy. What is the formula for potential energy? mgh. Is m given to you? M is only the mass of the brick is given to you. They are telling you to find the gain in the potential energy for the brick and the container. So please do not get confused. Brick and the container, the mass which is given to you is just 25 kgs. This picture that you see here, that I have taken forward from the first part of the question. This information which you have here, I have put it on the second screen as well. So what should be the value of m that you input here? You do not know the total mass of the brick and the container, but you know the total weight. So what is the formula for the weight? Weight is equal to mg. You know the value of mg together. Mg is 350 newtons. So you'll use the term 350 here for both m and g. And how much is the gain in the height? Height is the distance traveled, and the distance traveled is given by the velocity or the speed multiplied by time. So for how much time was it traveling at a constant speed? 25. And what was the constant speed? So 0.64 times time, which is 25. So this is your height. So you have to multiply 0.64 times 25. Multiply these three numbers on your calculators and you should be getting your answer. So you may pause the video here for a moment, and then I'm going to show the mark scheme, tally it with the mark scheme. See, they also have done the same thing. Your answer should be around 5600. 5600 joules. Alright, so this is done. Calculate the power required. You know the potential energy. So what is the formula for power? Power is energy over time. So all you have to do is to take this energy over the time value, which is 25, and you should be getting 25, right? Here 25, and you should be getting your answer. So that's one way of doing this question. Another way of doing this question is power is force multiplied by velocity. What is the force? Force is the weight, which is 350, multiplied by the velocity is how much? 0.64. That's another way. So whichever formula for the power you are using, energy over time or work done over time or force times velocity, you should be getting the same answer. So what is your answer? You want to see? You want to tally your answer? I'll show you the mark scheme. If you are getting this as the answer, 224 watts, you are correct. So here also mark scheme says two ways of doing this question. F is either you use the formula power is equal to FV or energy over time, work done over time. Any of the formula makes sense, or potential energy over time. Everything makes sense. So the answer is, final answer, 224 watts. Alright, so makes sense. Easy questions. Looks like the questions are straightforward so far. Let us look at question number 3 now and find out what kind of a question is it. Is it also going to be easy like this? We'll find it out when we'll work on it. Stay connected.